So let us now do another set of basic algorithms related to integers. So if you remember, there is this thing called the basic Euclidean division algorithm for integers, right? You take an integer, you divide it with a smaller integer, and then you get a quotient and a remainder. Is that right? So let's write an algorithm to do that. So what is the structure? You are giving the dividend and divisor. Okay, the larger number and the number with which you have to divide it, and then the output has to be the quotient and the remainder. Okay, so that is how you have to do it. So let's start. Write an algorithm to perform the Euclidean division algorithm for, let's say, just for positive integers. Okay, let's not worry with negative integers, so non-negative. Okay, the input is the dividend and divisor, and the output should be the quotient and the remainder. Is that okay? So let's start with that. So let's call this, let's give it something. Let's call this Euclidean division algorithm. Okay. And the inputs are A and B. And let's go in this order. A is the dividend and B is the divisor. Okay. So all right. So let's give it the same name. Dividend divisor. Okay. I mean, it doesn't matter. Any name is fine. So instead of trying to remember what it is, let us just give it that name itself. So we have start and stop. All right. So what is the first thing that you have to check? Both are non-negative integers. I mean, you can check that, but we don't really have to care about it. Okay. So let's just assume that both are non-negative integers. The one thing to check is the following. If the divisor is 0, then you cannot divide because 0 does not divide anything. Right? So that is the only thing that you need to check. If divisor is equal to 0, then you have an error. What is that? Division cannot be done because 0 cannot divide anything. Remember that? Else you're fine. Else now you can start dividing. Okay, so the divisor is greater than 0, and now you can start dividing. Okay. So what do you do? How do you compute the quotient and how do you compute the remainder? So let's initialize a few variables. Let's call this quotient. Let's call it 0, and remainder. Let's call this also 0. Okay, we have given them these values. All right. Now the quotient is this. The divisor, you can, instead of dividing really, it's subtraction, right? The number of times you can subtract the divisor from the quotient, from the dividend, that is the quotient, right? The number of times you can subtract the divisor from the dividend, that is the quotient. Is that correct? And it has to be non-negative. So you can subtract it as long as the subtraction is non-negative. Okay. So first of all, suppose you cannot divide at all. Okay, if the dividend is smaller, quotient is 0 and the remainder is supposed to be the divisor itself. Okay, so uh, let's not initialize remainder to 0. Let's initialize it to the divisor value. Is that okay? Right. So now what do we do? Any ideas? So here is what we do. Okay, so this is what we do. We keep performing this for as long as the value is non-negative. So the loop is a while loop. Okay, so let me just make a small change. In fact, we will need these variables. So a comma b, and let me set them here. Okay, dividend equal to a, divisor equal to b. Okay, now we are fine. Okay, what is a while loop? So while loop goes like this. It's slightly different from for. While says while, if you put this condition, some condition here, and then you have end while, right? And then in between you have code, right? So what this says is whatever is here, okay, whatever is here will get repeated again and again and again and again as long as this stays true. Each time it will check, is this true? Then do this. Then again, is this true? Do this. Again, is this true? Do this. At some point, this will become false and then the while loop ends. Okay, so that is what we are going to use. So the while loop says, while, what should we do? As long as the dividend is greater than or equal to divisor, right? As long as the dividend is greater than or equal to divisor, what should we do? Let's change this. Dividend equal to dividend minus divisor. Okay, so we have removed one copy of the divisor out of the dividend, and that copy, that count should go into the quotient, right? So quotient equal to quotient plus 1. You understand? As long as this is true, dividend, from the dividend you remove one copy and then you add 1 to the quotient. Then again you remove another copy, add 1 to the quotient. Again another copy, add 1 to the quotient. The number of times you can subtract divisor from the dividend, that is equal to the quotient. And then what remains? Then what remains is the remainder. Okay. So once, when will this come out of this while loop? Exactly when the dividend becomes strictly less than the divisor. The moment the dividend becomes strictly less than the divisor, we come out. But then where is the remainder? Remainder is exactly saved in that remaining portion of the dividend. Okay, because it's now strictly less, we have taken it out. So now remainder is equal to dividend, whatever is remaining in that variable. Okay, so just check this algorithm over something. Let's say A is equal to 8 and B is equal to 4. Okay, just try running this and then you will see that this is perfectly okay. Okay, so the idea is the quotient is a number of times you can subtract the divisor from the dividend while keeping the difference, rather while keeping the dividend greater than or equal to divisor. Once that is done, the moment the dividend becomes less than the divisor, you stop. Okay, and then the remaining part in the dividend, that itself is the remainder. Okay, so that's the basic part of the Euclidean algorithm. So that completes in this. Okay, what do you have to return now? You have to return now the two values. So you return not one value, you return the pair quotient comma remainder. Is that okay? You return the pair quotient comma remainder. Is that okay? So that is the algorithm for performing the Euclidean division. Okay, once you have this, so you can take a pause, but let me continue. Once you have this, What is the first thing you do once the division algorithm is studied? You try to compute the GCD of two numbers, right? You try to compute the GCD of two numbers. All right. So let's try to compute that. Okay. So write an algorithm to compute the GCD, greatest common divisor, of two, let's call it positive integers this time. Okay. We don't want to play around with zero. Okay. GCD makes sense for positive integers more. So positive integers, and we have to use the Euclidean division algorithm in order to do that, right? Okay, so how do we do this? So now it's called GCD, A comma B. All right, all right. So now if this is not remember, if you don't remember this, just go back and revise or do a Google search for how you calculate GCD using the Euclidean algorithm. Okay, I'm assuming that you know how to calculate the GCD using the Euclidean algorithm. Okay, so that is what we are going to do here, right? So the first step is to compute the is to divide the larger number with the smaller number. Is that okay? So if A is less than or equal to B, or let's say A is greater than or equal to B, okay, the two numbers, what do? You need to try and divide A by B. Okay, so note that here we had this order. Okay, we were dividing A by B, so that order we have to keep. Okay, all right. So let's do that. So then we compute the quotient and remainder via the Euclidean division algorithm. Okay, A by B. Else, we need to do the reverse. If A is less than B, then we need to do the reverse. Is that okay? And then we do end if. This completes the first step. What do we do now? Do you remember? Now the thing is, the remainder becomes a new divisor, and the earlier divisor becomes the new dividend. You understand? So this is the thing. The quotient really is not very important to us. Is that okay? All right. So let's take a value. So now let me initialize one more value, GCD, which stores the value 0 for the moment. Okay. For the moment, takes the value 0. Now we are going to modify this. Is that okay? Temporarily, let us save the value of remainder in GCD. Is that okay? All right. So temporarily we save this, but when do we return this value? The next time you perform this, The next time you perform this, the remainder should be 0. Is that okay? So let's do that. So now let's change this. Quotient comma remainder, the new one is going to be Euclidean division. Earlier the divisor was b, right? That becomes the dividend. And now the divisor becomes the remainder. Okay, the old value of the remainder, and you will get a new value for the remainder. Is that okay? Is that okay? But how long do you perform this? You perform this for as long as the remainder is non-zero. You understand? So here is the thing. We perform these two steps for as long as the remainder is non-zero. So while the remainder is not equal to 0, I'll store that value as a GCD. I perform this, okay? And then the new remainder, the moment it becomes 0, I stop. The moment the new remainder becomes 0, at whichever step it becomes 0, I will stop. But then the old value of the remainder is already here in GCD. And that is the correct value of GCD. You understand? So, sorry, in small letters. Right. So that is it. End y. Okay. Else I'll have to repeat this. So the same thing, but I'll just have to repeat this for this thing. So else, but now it's a. Okay, that's it. So once again, to start, if a is greater than or equal to b is greater than or equal to a, that we just have to make a choice. Okay, suppose a is greater than or equal to b, we get quotient and remainder by applying Euclidean division. If the remainder is non-zero, perform it again, but then by replacing the divisor with the remainder and the remainder with the, sorry, by replacing the dividend with the divisor and the divisor with the remainder. Okay, and then calculate the new one. Keep repeating this until the remainder is non-zero. The moment the new remainder becomes 0, we stop, and the GCD is stored in the old remainder. Right, so we have the value of GCD here. On the other hand, if A was less than B, then the first step has to be reversed. So we'll do else and then do this whole thing again, but with B and A in the reverse fashion. Is that okay? That is all that we have to do. And once we have this, the GCD value is stored in the GCD variable. So else return just the GCD value. Okay. So that completes the computation of the GCD. Now quickly, let's also do the LCM. So compute the LCM of two. LCM is much easier now. Why is that? Because there is a relationship between LCM, GCD, and product. Okay, so we can use the GCD algorithm to compute the LCM. All right. So this is what it is. I am just going to return GCD into LCM is equal to A times B, right? GCD of AB into LCM of AB is equal to A into B. So the LCM of AB is just A into B. Let's put it in bracket, divided by GCD A comma B. That's it. I don't have to do anything else. Okay. Basically, this is computation of GCD itself. I do that here, and then I divide it. I divide the product of AB by the GCD, and that gives me the LCM. Is that okay? So this completes one section of algorithms on the Euclidean division algorithm. Okay, so I'll stop here.